We're moving into function and function notation, and then we'll also look at domain and range. Domain and range will be a different video. Let's start with defining what a function is and then looking at function notation. You may have heard what a function is before, so this might be a review. We're going to look at different situations to be able to determine if we have a function or not. A function is a relation that for every domain value, there is at most one range value. Okay, that may be really confusing because what is domain and what is range? We haven't defined those yet. We will, and we'll look at how to find the domain and range shortly, but let me just kind of give you a little heads up. The domain value represent your x values of a coordinate point, and the range value are your y values, the output of a coordinate point. And just to remind you, a coordinate point is x, comma, y. Think alphabetical. So down here in this box, it says, what does that mean? So what does that mean? That means that the x values may not repeat with different y values. So if you look at the points that you're given or look at the graph, you're looking at your x values. Remember, the x values are the ones that are on the horizontal axis. Do any of them repeat with different y values? If they repeat with the same y value, that doesn't count. It's if they have different y values. So let's look at how we determine when something is a function. So we're going to look at two different situations. It says, how can you tell if a relation is a function? So if you have a table of values, remember, it could be up and down, it could be sideways, it could just be a list of points. You're going to see this, and I put all of it in the next example. Check to see if the x values repeat with different y values. If they don't, it's a function. So if your x values are all, you don't repeat, and when you say them, you don't repeat them with different y values, you're good. It's a function. So let's look at this example. It says, which relationship is a function? So if you look, I have several different types of tables. I have a list of points. It's all the same. So if we look down, we look at our x values. So in our first box, if we look at our x values, which are here, do any of those x values repeat? 10, negative 2, negative 10, 5. No. So that is a function. So our answer to this would be this one right here. We would check that one right there. Let's look at the other three just to show why they're not functions. So if you look at the next one, if you look at this one here, you see a 1 and a 1 in the x. They have different y values, so that means that's a no. This box down here, you have a negative 4 and a negative 4 in your x values with different y values. So that is a no. And in the last one, you have a 1 here and a 1 here, and they have two different y values. So that is a no. So that's why all the rest of those three are not functions. So you're looking to see where your x values don't repeat. If you're given a graph, check to see if the vertical line test passes. And what you do for the vertical line test, you draw a vertical line. So think your pencil. If it only hits the graph in one spot all the way across the graph, it is a function. So let me summarize what the above says. And you don't have these two graphs on your paper, so you might want to pause and go ahead and draw them in. So this right here, I'm going to treat this as my vertical line, right? So if I come across this first graph, if I take this vertical line and move it across the first graph, does it hit the graph in more than one spot at a time? It doesn't, does it? So it's one there, one there, one there, one there, and it keeps coming across. So that's what we mean by the vertical line test. Does it hit the graph in more than one spot as it moves across? In this case, this is a no. So that means that this is a function. But if we take this vertical line again and move it across this one, so if I move across here, what happens? It hits the graph in that spot right there. Well, anywhere after this point, it starts hitting it in two spots, right? So it hits that line here and here. That would not be a function. Okay, so keep that in mind. So let's look at the graphs and the examples that are below here. So this first example, if I take my vertical line, you could use your pencil, and if I come across the graph, so if I come across that graph, I am not seeing any point where it hits the graph in more than one spot. So if you look here, it does not do that. So you would write, this is a function. Do that for the second one. If I take my vertical line, use your pencil. If you come across here, it's hitting in multiple places. My line's not too long, but it would hit anywhere after that, right? So if I come here, at that point right there, it hits here and it hits here. And so this is not a function. So function notation, let's move into that now. So we know how to identify a function, and let's figure out what function notation means. Function notation is just another way of writing and determining values for a specific role. It allows you to see specific x value that is needed to be substituted in. That's what's kind of nice. So I have two examples there of what it looks like. So what does function notation look like? Well, the first one, f of x equals 3x minus 2, this is just the same as saying y is equal to 3x minus 2. It's just a sophisticated way of saying y, f of x is. But it means a function. So that's why we use the f of x. And that's how the f is read, f of x. When you see this, all that means is a point. This here is your x. This here is your y. X comma y is your point. And so this is just saying that when x is 2, y, or f of x, is 4. That's what that means. So the thing that's sitting in, if you look, this is f of x. So that's why the 2 is the x, and the result is the y. So just think of f of x as another way of writing y in the equation. The whole f of x. But the actual value of x is x. To evaluate something like f of 3, remember this here is your x. So you put 3 into the function f of x for x. You're going to see me demonstrate this here shortly. So let's just look at some examples of function notation. The first example says, the graph below shows relationship D. Find D of negative 2. So find D of negative 2. So what you're doing is, remember, negative 2 is x. So you're going to go on your x-axis. Remember, your x-axis is this guy right here. And you're going to find negative 2. So negative 2 is right here. And then what you have to do is go to the graph to find the y value. So if I come up, it hits right there. So that means that D of negative 2 is equal to whatever this value right here is, which in this case is 3. So that's how you find using function notation with a graph. The thing given to you is always the x. Find the x, go to the graph, find the y. Example number 2. We have j of x is equal to 1/2 x plus 1. So it says find j of 6. So remember, 6 is the x value. So in the j of x, you're going to do j of 6 is equal to, and then you're going to do 1/2, and every place you see x, you're going to replace with a 6. So that's how you're going to set that up. The j of 6 doesn't do anything. You can't do anything with it. And then you evaluate this rest of it. So what's 1/2 of 6 plus 1? So 1/2 of 6 is 3, and 3 plus 1 is 4. So that means that j of 6 is equal to 4. And in GMM, you would just write 4. You don't write j of 6. Example 3 says, which ordered pair, if included in the set, would cause the relation to no longer be a function? So this is going back to functions. So if you remember, functions, we're looking at our x's. So right now, those x's do not repeat. In order to keep it a function, we can't have them repeat. The question says, which ordered pair, if included in the set, would cause the relation to no longer be a function? So that means that one of my x values have to repeat. So which point down here makes one of my x values repeat? Well, 1 isn't in my x's, so that wouldn't. Negative 2, that's not in my x values already, so that wouldn't. But negative 8 is up in my x values. So the answer to this would be this one right here. So you would check that one. I included number 4 because it's a tricky question. Because it says find k of 3. And if you look, k of 3 is right here. So 3 would be right here. So that means that any number here would actually make it work. But that means that x has more than one y value. So this does not pass the vertical line test. So the answer to this type of question, anytime you see a vertical line, the answer is going to be this down here where it says not a function. So be careful with those. That's not true for a flat line. It's only true for an up and down vertical line. This last example I thought was really important for me to put on because you guys really haven't seen much with, this is called a step function. If you look at it, it looks like steps, right? And you really haven't done much with this, but you're going to have questions in GMM that asks you if this is a function or not. And so I want to show you how to tell if this is a function or not. Okay? The big thing that I want to quickly show you or teach you is that just like in inequalities, an open circle means it's not part of the graph. And a closed circle means that it is part. So when you're trying to evaluate if this is a function or not, I'm going to use my vertical line. Again, you could use your pencil. So as you come across this, at this point right here, it hits the graph in 2 spots, doesn't it? But one is included and one is not. One is part of the graph, one is not. So that doesn't count. That's good. All right, we don't have to worry about that as a double point. If we continue coming, at this point right here, we have 2 points again. Those are both part of the graph. So that point right there tells us that this is not a function because the x value has 2 different y values, right? So because this was not, this point here, this point right here is not part of the graph, it didn't affect the functionality of the graph. But when we get over here, these are both included, so that means that is not a function. So you would write not a function, or you just wouldn't choose it as one of the options. If you have something that has all open circles though, a step function with all open circles, you're good. It's a function. So you have 5 your turns to do. They should not take you that long. Most of them are multiple choice. So please do these. So you could tell whether or not you know what a function is or not, and you know how to use function notation or not. Have a good night.